Hi, and welcome to the session on best practices for data security in the Experience Cloud. I'm Savvy, and I've been in the Salesforce ecosystem close to a decade now, architecting and solutioning for mid-size and enterprise organizations across industries, leveraging multiple Salesforce products and ancillary technologies. This is a session that I presented at Dreamforce 2023, and thanks to all who could make it in person. But for those who couldn't, here's a recorded version. So let's kick things off by setting a scenario. Imagine this. You recently launched a help center site within a record 3-month timeline. Your customers are providing great feedback, the business is thrilled, and your in-house Salesforce engineering team is getting rave reviews. Now fast forward a month, it's a nice Sunday afternoon, and you're enjoying some downtime with friends, and suddenly your phone rings. You also notice an influx of messages on your Slack channels. With all that anticipation, you answer the call only to discover that all of your customer data has been leaked and posted on a public forum. In an instant, your entire world changes. You drop everything and become laser focused on finding a solution. A few stressful hours in, you figured it out. There were some excessive permissions on the guest user profile that caused the data leak. So the fix itself was straightforward, but by now you've already lost your customers' trust, and the effort required for damage control is huge. Moreover, all the effort that went into building the stellar site, which met all the business requirements and received great customer feedback, can quickly go down the drain due to the absence of a security validation process. This session aims to ensure that none of us find ourselves in a similar situation. And to help with this process, I would like to introduce you to what I've called the Experience Cloud Data Security Rulebook. It is a consolidated list of rules that you can apply to build secure sites on the platform. Everything that I cover in the session is also available in a Medium article, and I'll share the links towards the end of the session. I intend to maintain this article moving forward with necessary updates as technology and security threats evolve. In this session, we'll begin with a few functional and configuration-based rules first before we get into the core technical ones. So let's get started with rule number 1 that states, define personas with granular capabilities. As straightforward as this may appear, it's a fundamental oversight I've encountered in various implementations. More often, I've observed the use of prioritized feature backlogs, which is great, but it's equally important to view these features through the lens of the user or the personas who are interacting with your system. This approach not only provides insight into the data access requirements, but it really drives your security and permission engine. If you're unsure about who should have access to what data, it becomes very challenging to determine how to safeguard it and from whom. So let's look at an example of a help center site just so you can see how to go about this process. At the very top, you want to have a clear separation between your external and internal personas. On the external end, you could have an unauthorized guest user who has access to the public knowledge base, and then from there, a registered member who can do a lot more, such as creating a case or interacting with other members of the site via posts or comments. You can further classify members based on subscription level or other categories if it makes sense. Now, when we look at the internal side of things, you can establish multiple roles aligned with your organization's job functions. In this example, I've defined the community admin and moderator as distinct personas. In practice, these roles could be fulfilled by a single individual, but maintaining separate access controls at this level is valuable because it offers flexibility as the organization expands and responsibilities are divided. Now, once defined, make sure you have a document that maps the personas and permissions, and I'll elaborate on this further in a subsequent rule in this session. Now, if you identify the need of an unauthenticated guest user persona, this following rule holds significant importance, and that brings us to rule number 2, which is scrutinize unauthenticated guest user access. Now, data leak of any kind is not good, but if it's through an unauthenticated route, you're making it way too easy. On a positive note, Salesforce has done a fabulous job over the last 2 years completely locking down guest user access. The documentation on this topic is very thorough, so I won't cover all the details, but will highlight a few key ones that I've stated here. So in its current state, guest users can't own any records in your org. They can only get a maximum read access, that too through a special guest user sharing rule. They cannot have view all or modify all permissions on objects, nor can they have update or delete permissions on objects. Lastly, run flows for guest users is also no longer supported. Instead, you need to use the new flow permission structure. I'm assuming that many of you would have made the necessary changes to comply with these guest user policies. And what all of this means is if you're building a site from scratch on a net new org, you already have a substantial level of protection by default. However, if guest users had access to records before Winter 21, they will continue to have access until you secure them. Now, to help secure access, you can leverage this free app from Salesforce Labs called Authenticated and Guest User Access Report. That gives you an overview of the objects, records, and permissions that the running user has access to. So you can then run this as a guest user and quickly identify areas that pose a potential risk and prioritize the fixes. Once you've locked down the guest user access, you can also use this app to schedule a job to run these reports to proactively monitor and get notified for changes to the guest user access. This app is also supported with thorough documentation that is actively updated with the new releases, so I would highly recommend that you check this out. Furthermore, a few additional considerations I'd like to address regarding guest user access. The first one is related to enabling public access to your site. When you do so, do this at the individual page level instead of the site level. This allows you to keep the overall site gated and open up specific pages as needed. Obviously, this wouldn't apply if, say, 90 to 100% of your site is public. Now, once you have opened up public access, you can further control what's exposed by leveraging page or component audience variations for the guest user or component visibility rules if you're on LWR. When it comes to the guest user, always apply the principle of least privilege. For example, when you look at this user profile page, the question you want to answer is, does the guest user need access to all these data points? Or probably just the community nickname and the publicly available post? Or can I completely lock down access to the user profile page? So these are some of these decisions you want to make upfront and document them to ensure that all your team members have a clear understanding of what guest user access means. Once you established guest user access, it's equally important to dedicate some time towards testing. Open up your site in an incognito window, browse to the public and object pages and verify access. Perform a global search across various objects. That's one way to quickly identify overly broad access to records. Many of the data leak incidents I've encountered stem from some security misconfiguration related to the guest user access. So if there's one rule I hope you take away from the session, it's this: secure guest user access. Now, once you define personas and their capabilities, you need to set up access within the system. And that brings us to rule number 3 that states, manage user access with permission sets. Unless you're relatively new to Salesforce, you're likely aware that the future of user management revolves around permission sets. With Spring 26, that'll be the end of life of permissions on profiles, post which only the following settings will remain on the profile. So those are the login IP ranges, the record types, and page layout assignments. Again, there you have an alternative with App Builder or Dynamic Forms. Now, if you're wondering why this rule made the cut and what's the security concern here, the main issue with profiles is because of its monolithic nature, it doesn't really allow for modular feature-specific assignments. And over time, it gets difficult to keep track of all of those permissions, which then results in errors granting undesired access. Secondly, the end of life is still 2 years away. So I want to ensure that everyone has a plan in place to transition to permission sets. There are a lot more benefits of moving to permission sets that I can't cover in this session, but I would recommend you watch the session from Louise Lockey called Build a Permission Set Led Security Model, where she covers this topic in great detail. Now, to help with this transition to permission sets, you can leverage these new features under user management settings. The first one's called user access policy and lets you automatically grant or revoke access to permission sets groups, queues, groups, permission set licenses, and managed package licenses. These can be triggered on the user create or update, or you can have a one-time manual application of a user access policy to migrate or change users' assignments. These policies can also be selectively applied to a subset of users via conditional filters. The second feature is called field level security for permission sets during field creation. Once enabled, the users will be presented with a list of available permission sets instead of profiles when they create new fields, which just further enforces a permission set-based security model. In the future roadmap targeted for Spring 24 Safe Harbor year, you can turn off the ability to use permissions on profiles even before the official end of life, which I recommend everyone does, so then no user can go rogue once you've completely migrated to permission sets. Now, after you made this transition, your persona and permission mapping template could look something like this. You can have profiles that are used as a shell for license and potentially page out assignments. You would then create feature-specific permission sets, and then you have a one-to-one relationship between your persona and the permission set groups, where a permission set group is just a collection of those feature-specific permission sets. From here, we move to rule number 4, that is define and secure personally identifiable information. Firstly, from a business perspective, you need to have consensus on what data points are deemed as PII, and then once defined, you need to secure them leveraging platform capabilities such as Enhanced Personal Information Management or EPIM. The way this works is there's a field set on the user object called Personal Info EPIM, which by default has a set of fields that Salesforce has deemed as PII, but you can adjust them as needed. And then for every field in this field set, even if this exists on the page layout, to an end user viewing another user's profile page, it'll be displayed as blank, or in the case of the name field, this will be replaced by the community nickname. This is great as it's all managed via config. Every out-of-the-box component respects this setting. However, there are a few caveats. The first one, this isn't enforced in Apex. So if you have a custom component that queries these fields in Apex, this setting isn't enforced. Secondly, in its current state, this feature is only supported for the user objects. So if you have PII on other objects, more commonly say the contact, then you would need some custom handling here. On the positive side, you can apply the same principle, that's query the field set in Apex and then grant or revoke access as needed. This brings us to the last rule related to configurations. And rule number 5 states, know and review your global and individual site settings. The common pitfall that I see here is there are certain out-of-box components that require some of these settings to be enabled. And often when there's a time crunch, we end up choosing the easier path of enabling all the options, which works, but now you have inadvertently opened up access that you shouldn't have. So it's important to understand these settings and their security implications. The first thing to note here is that these are managed at the global level that apply to all the sites in your org and at an individual site level as well. So let's start with the global settings first. There are 2 types here. The first one is digital experience settings, and these apply to all of your sites. The recommendation here is to stick to the default state as far as possible because it's the most secure. And there are quite a few settings here, but I'll cover a few ones. The first one that's disabled doesn't allow external users to see contacts that have not been enabled as partner or customer accounts, which makes sense because very rarely will an external user want to see an internal contact. The second one, disabled, doesn't allow the use of your standard profiles for self-registration, user creation, and login, because these standard profiles come pre-enabled with a lot of permissions that you may not need. And moreover, with the recommendation of moving towards permission set, the best practice is to really create a custom profile and just use that as a shell, as we discussed previously, and leverage permission sets to drive all of your permissions. Lastly, hide batches from guest users is enabled. Again, applying the principle of least privilege. If they don't need to see something, you don't need to provide them information. And there are some nuances here. The badge metadata also contains some PII information in terms of who was awarded the badge, which could contain first and last name information. So it's these nuances that you need to be aware of. From here, we move to the second setting, that's user visibility setting. And there are two types, portal user visibility and site user visibility. When you enable portal user visibility, the user has access to all the other users in the same account as them. So if you look at this example, from John's perspective, John would be able to see Sasha's user record because they are under the same account Acme, but not Rahul, who's under a different account Google. However, if you enable site user visibility, then the user has access to all the users of the same site. So going back to our example here, John would be able to see both Sasha as well as Rahul. But site user visibility works in conjunction with an individual site setting, and that brings us to site-specific preferences. So for an authenticated user to view other members of the site, you need to enable both the global site user visibility setting and this setting that says see other members of the site. A few important settings related to guest user here. The first one gives the guest user access to assets like images and CMS content. This is automatically enabled the moment you have at least a single public page in your site. The second one provides access to chatter feeds and discussions, more so relevant for a community forum implementation. And the third one gives the guest user access to view members of the site. A slight nuance here, if the guest user needs to access chatter discussion and post components, you need both these last two settings to be enabled, which opens up access to the user profile page, but as discussed previously, you could lock it down through an audience variation. So that's why it's important to understand all of the different options that are available at hand. Lastly, always use nicknames. This is enabled by default, and once enabled, it's displayed everywhere on the site where the user is referenced instead of their first and last name. This brings us to the end of the functional rules. So let's do a quick recap. Firstly, define your personas. If you've identified the need of an unauthenticated guest user access, secure and lockdown access, leverage permission sets for user management, create a persona and permission mapping document, define and secure PII, and lastly, as far as possible, lock down your global and individual site settings. From here, we move to our core technical and developer-specific rules, with rule number 6 that states, check for object CRUD access and field level security in your Apex UI controller methods. You've probably heard this a million times in the context of Apex best practices, but the question I often get is, do I really need to check access at an individual field level? It feels like an overkill. How can someone exploit this? So let me clarify that with an example. Here we have a partner portal with 3 different personas. You have a partner member with standard access, you have a partner member with elevated deal management access, and you have a partner admin who can manage partner account information and provision other members. The component you see here is a custom Lightning Web component that captures some user details, provides information about the different access types, and has a button to request elevated access. The developer who built this component thought about reusability and is leveraging the same Lightning Web component and underlying Apex methods, just enabling or disabling certain features based on the logged in user. So when it's the partner member, they just see the access level as assigned to them. But when it's the partner admin, they're able to edit this access level for other members. The developer's using conditional DOM rendering based on the logged in user profile to show this text versus editable input. So you wouldn't be able to manipulate the UI state just with CSS or JavaScript in your browser. So they've done the right thing here. Now, when we look at the Apex method, it's again pretty straightforward. All the form elements that we saw previously are exposed as input parameters here. When it's not a partner admin, specifically for the access level, the same info that is fetched for display is passed back as the input, so there are no changes there. And from an access standpoint, only the partner admin has the delegated external user administrator permission, so only they can update other users' information. From a developer's perspective, they have done all the right things to lock down access based on the logged in user context. But what often gets missed is when you have a UI controller public method with the Aura enabled annotation, the Salesforce framework is making it available to the front end via Aura site APIs. For any given site, you can easily reference all of the site APIs by simply inspecting the network tab via the browser dev tools, as you can see here. Now, if I zoom into the payload, you will notice that this exposes your method signature. And once I have this information, I can easily make the same request through a tool like Postman, manipulating the payload to get elevated access. So in this case, the partner member can manage their own access level, which is not what the developer intended. So if we look at this request again, just to highlight some of the key parameters here, the first one is this message attribute. That is what you would manipulate to exploit a potential misconfiguration on the security side. The Aura context contains the framework ID and your site ID. The Aura page URI can be as simple as /s or the page that contains your component. And the Aura token is the current user's token. For a guest user, this would be null. The Medium article that I have includes these Postman requests as well, so you can just import and test this yourself. Now that you've seen how easy it is for someone to hack into your custom Apex methods, the fix here is to really ensure we are enforcing object and field permissions. Now, until recently, this was quite cumbersome to do natively in Apex, but now with all of the new methods, you have a lot of simpler options to enforce these permissions. The first such option is user mode for database operations, and you can use this while performing an query just by using the with user mode suffix, or doing a DML statement, you can say insert has user as in as example, and that would enforce all of the FLS and the object permissions for the running user. This also applies the sharing rules, so it basically checks for record visibility as well. Salesforce recommends that you use the with user mode option rather than the previous with security enforced because of all of the additional benefits. I'll call out a few. This accounts for polymorphic fields like owner and task.whatID. It also finds all of the FLS errors in your SOQL query, while with security enforced only finds the first error and stops there. Now, alternately, you can use security.strip inaccessible method that strips the fields and the relationships fields from the query results. Or if you really need granular field level handling for these checks, you can fall back to schema.describe as object result methods. So in this example, the developer made the assumption that everything is locked down from a UI standpoint, and there's no other means to perform the same operation, which we saw wasn't true. And that brings us to the next rule. And rule number 7 states, data accessible via the user interface and API should be consistent. Let's look at another example so you can understand this a little bit. In this case, you have an existing implementation that utilizes the out-of-the-box user profile component. There's a new requirement that's come your way as part of the integration with Marketing Cloud, which requires you to copy over some information from the user object to contact, since on Marketing Cloud, you have the contact ID as a unique subscriber key. From an implementation standpoint, you followed all the rules so far. So you've added the PII user fields to the PII field set. You've provided edit access only to the contract fields that are being copied over. In this case, you're using an Apex trigger because there already exists one and you didn't want to have another entry point with flows. However, you made sure that you enforced CRUD and FLS checks. And there are no other site pages that you've intentionally exposed that work with the contact record. Now, unlike the previous example, since there's no UI controller involved, none of your logic of copying of the fields is also exposed. So at this stage, everything seems to be quite solid from a security standpoint. So what could go wrong? Just as you build custom components, the out-of-the-box Lightning components you leverage also work with underlying Salesforce APIs, such as the UI API to fetch data. Now, these APIs strictly comply with three things: the object CRUD, FLS, and record visibility that's granted to the running user. Now, in this case, since you've granted the running user access to those contact fields, I can then exploit that using the same concept as before. The only difference is now we are working with a native Salesforce API, specifically the UI search API in this example. So in this case, going back to our same example, John can now fetch his own contact record via an API call. Although this potentially exposes some internal fields that the user shouldn't access from a security standpoint, is it too bad since they're viewing their own information? But what if I tell you that this can be further exploited? So let's move on to our next rule to understand how, and then we'll discuss the potential fix for both of these issues. So rule number 8 states, review the impact of implicit sharing. Considering implicit sharing often gets missed when it comes to external sharing for site users. Site or portal implicit sharing provides access to the portal account and all the associated contacts for all the site or portal users under that same account. So going back to our same example, from John's perspective, John can now see the account ACPay as well as Sasha's contact record. Now, don't confuse this with the user site visibility settings. There, we are talking about the user object. Here, we are talking about account and contact. So now that I know this, I can use the same previous API, the search API, but in this case, John can not only see their own data, but they can also query Jane's contact info, which is a data leak and a much bigger problem. The fix for both of these issues in this example is understanding that this is a backend operation that doesn't really need to run in the user mode and can run in the system mode without giving the running user access to the contact fields. Even if you use flows instead of Apex, you have an option to run flows in the system mode. So there as well, you can manage this. That brings us to the last rule, which is rule number 9, and it states, use without sharing sparingly and with necessary safeguards. Although without sharing should be the last resort, there are certain scenarios where you may need to use them. For example, because of the new guest user security policies, a multi-step self-registration process that, say, couldn't be done via post-login flow may require some of the logic to run in a without sharing mode because the guest user cannot have edit permissions on records. So let's look at another example. In this case, we have a loan application form. And it would be great if I could get a loan just with those 4 inputs in the form displayed here. But we all know that's not the reality and there's a lot of steps involved. So when you have a multi-step process like this, even in that case, I would recommend using flows because the flow variables are maintained on the server side and can be securely referenced later in the flow. But let's say due to some UI limitation, you need to do this with Lightning Web Components, where on step 1, you've created the loan application record and then need to reference this record ID at a later point in the flow. If there is such a requirement, you need to make sure that you're encrypting the record ID in Apex before you pass to the UI. So that makes it very difficult for someone to hack into without access to your encryption keys. So now that we've covered all of these rules, how do you take this forward? As I mentioned earlier, this entire rulebook is available on this Medium article, and you can get to it by scanning this QR code. I've covered a few more additional rules there, such as CSP and click check protection, and a lot more details of the different rules I covered today. You can use this as a frame of reference to validate the security posture of your site. Then When it comes to web application security, there are these two tailored modules which have some really good content. So I recommend you read that. And lastly, since security is an ongoing concern, take the time to follow the latest security risk and trends. At a bare minimum, I would recommend that everyone is well versed with the OWASP top 10. I'll conclude my session by quoting Mark Benioff at the keynote this year. He said, "Your data is in Salesforce's product, and you control access to your data," which means keeping your data secure is a joint effort between you and Salesforce. Salesforce is doing its bit by providing us the guidelines and frameworks. However, we still need to implement them and do our bit. So that's all I had to cover. Thank you all for your time. If you do have any questions or feedback, feel free to post them on that Medium article or just reach out to me on LinkedIn. Thank you.